What are we talking about? The midpoints? Locus of the midpoints. Locus of the midpoints. Okay, so here's the plan. Instead of going the geometry route, let's try going the algebra route. One square root at a time. One square at a time. Patience, patience. Number 8. Consider all line segments of length 4 with one endpoint on the line y equals to x. Graphing. And the other endpoint on the line y equals to 2x. Find the equation of the focus of the midpoints of these line segments. Oh well, not drawn to scale. This is x, this is y, 2x, y equals to x, y equals to 2x. Well, there's gonna be one place where that's the last thing, and it's gonna be 1. What are we talking about? And there are gonna be some over here as well. The midpoints, locus of the midpoints. Locus of the midpoints. Okay, it's gonna be further down because it's symmetrical. Something like this. Okay, and then you're gonna have a bunch of points, lines that are like this. Just 1 unit away from not seeing anything. It's gonna be a little, looks like an oval, maybe. Very, very thin oval. Okay, so here's the plan. We're gonna find the coordinate of this, and then we're gonna find the coordinate of this and this. So those are the major and minor axes. And then we're gonna find the focal points. It'll be something like over here and over here, same length, by using the major and minor axes. And they're going to be down the angle bisector of the two lines. Yeah, angle bisector. I'll have to use angles too. And then once we find these two coordinates of the foci, we can derive the equation of the whole ellipse. I've just thought of something else after I turned off the camera. Instead of going the geometry route, let's try going the algebra route. So we have 2 points. One is on this line, so it's x1 and x1. And the other point is on the other line, so x2 and 2x2. We're going to calculate the distance, x1 minus x2, or x1 squared minus 4x2 squared. Okay, and that is going to be equal to 4. Sorry, all these ones are supposed to be 4. And that's going to relate x1 to x2. And then we're going to calculate the midpoint. x1 plus x2 over 2. x1 plus 2x2 over 2. If we can substitute out one of the variables, the x1s and x2s, we're going to get a locus. And then we try to express the y values in terms of x, and we're done. This way we can skip trying to prove that all the points that we want to consider are on an ellipse, and probably a whole ton of calculations in between with angles and angle bisectors and etc. Okay, so when we have time, when we get back to this, I'm gonna try the algebra route first. Let's put the midpoint formula up here. So we have some space. We're going to try to substitute one of them into there. Oh, what am I? No. That's not right. Nope. Try again. Yep. 16. Which one should we keep? x1 or x2? x1 looks cleaner in there, I suppose. x2. And so this is A, this is B, this and this combined is C. Let's give a little more space. Oh, no. I need the x1s in there. Do I just keep it? I guess. Here's an expression for x2. It makes sense for it to have 2 answers for every x1 because, let me just draw it here. For every point on this line, there are 2 points on the other line that forms a 4-unit line segment. So we're just gonna keep the plus and minus, I guess. So we want an equation relating these two. And right now they're both in terms of x1. We don't need an x1 in our final equation, so we can substitute it. This is x, this is y. Which one's easier to work with? Solve for x1 and then plug it in there. We're gonna end up with a quadratic somewhere too. Move it all. I can divide out a 5. We're going to solve for x1, so this is A, this is B, this and this are C. Let's try. I'm pretty sure I can take out some. We can take out a 4, that's it. Get rid of a 2 there. Let's clean this up a little. We're going to try to plug it into the y, and here's our x1. Let me just put the 10 on the other side because it's kind of messy. This squared, that's a lot of square roots. I could try to do it after. Let's not plug it in right now because it's kind of messy. Let's get rid of that square root first in the original expression. We're going to square both sides. Okay, move it to this side. We can get rid of a 5. I could just put all of them on one side. The x1 is on one side. And then plug this in. So this is A, this is B, this and this are C. 2036. That's 64y minus 6400. And we can take out a 64, which will be an 8. Take out a 2. These two things are equal. See if we can move this back to an original equation for the locus. Oops, y squared. Oh, x. I was wondering. I think we can get rid of a 2. 1 square root at a time. 1 square at a time. Patience, patience. If we don't try to simplify it, this is my final answer. We're not going to go there because I ran out of steam. Accessibility of this question. Solving radical equations is deep into grade 11 probably, which is not bad. But I do suspect you need to know conics for this part. So that is definitely not part of K-12 curriculum anymore. I would say 1. Originality, yeah, I do think it's original, even though it's so algebraically involved. But I do like questions that relate pure algebra to the geometry side of things. I do like it. Yeah. Explorability, I really want to know if I'm right in assuming that if you have any two straight lines and you give it a condition like all the lines in between that have a specific length and you get all the midpoints, I really want to know if this is an ellipse in the end. 3. And I do like this question, yes. It's just a little bit out of reach. Maybe a lot, I don't know. And that's an 8 out of 10. That's a good almost 2 hours on just one question. But I had a good time.